Today's lesson is on logarithmic functions and their graphs. A logarithmic function is literally the inverse of an exponential function. So, let's first write out an exponential function. I like to write base to the exponent equals y. And our logarithmic version of that same one is going to be log base b of the y equals the exponent. All right, so we kind of have this counterclockwise rotation to go from one form to the other. So starting off, we're just simply changing form. So log base 8 of 64 equals 2. So again, this will be rewritten as 8 squared equals 64. If you're not confident with your changing ability, you should plug it into the calculator and be like, oh, does that work? 8 squared does equals 64. Same idea here, 2 to the negative 5 equals 1 over 32. And lastly, log base e, they shortcut and write as ln. They'll also do the same idea with log base 10. Instead of writing 10, they'll just write it as log. Like on most calculators have a log button, that is for base 10. So in this case, we've got e to the 3 equals e3. E cubed equals e cubed. Next, we're going to go the other way. Same exact idea, but we start with log base 3 of 1/27 equals negative 3. Continuing on. 125 log base 125 of 25 equals 2/3. And lastly, log base e, which is ln of 54.5981. So again, that just keeps going, equals 4. And that's kind of that general process. You should have seen something like this before, whether in Algebra 2 or Honors Algebra 2. Properties of logarithm, these are going to be similar to yesterday, but now we're in log form. Log base a of 1 equals 0, right? Because a to the 0 is 1. Log base a of a equals 1, right? That basically is a quick cancel. Look, people would consider that the quick cancel 1 as well. Right? Next, log base a of a to the x equals x, right? A to the x equals a to the x, and again, this bottom part equals 1, so it just cancels out and brings the x down. And the next one, a to log base a of x equals x. And again, it's understanding. What does this mean? This means a to a certain power equals x. Well, it stands for that power. Next up is, right, if log of base a of x equals log base a of y, then x equals y, right? If you have two logs that equal each other, same base, then your inside must equal each other. Right? So those are basic properties of logs. If you need to pause to write them down, feel free. Evaluate the expression without a calculator. Now when you run into one of these, if you're not confident, rewrite it into exponential form. Like this literally means 9 to what power is 81? Well, 9 times 9 is 81, and that is 2 9, so the answer is 2. Right, so you could have written that as 9 squared. Right, so the answer is 2. What about log base 3 of 1 over 81, right? So this means 3 to what power equals 1 over 81, right? And if we're a fraction, that means x is negative. So we're basically saying 3 times 3, got 9 times 3, 27 times 3, 81. So 3 to the 4th is 81. 3 to the negative 4th is 1 over 81, right? Not negative. So negative 4 is our exponent. Moving on, use a calculator to evaluate the log. Round to 3 decimal places. So make sure you have your calculator out. And now you've got the calculator out, right? Log of 15. So again, get you back to your original. We hit log button, 15. Didn't have a base on there, so it's a standard log in your calculator. round to 3 decimals, right? 10 to a power, not going to be a nice power to get to 15. So 1.176 is the answer. Next, log of 10,000. Same idea, although this one you can just count the zeros. We got 4. ln of 0.345. So now the button below it, ln 0.345 equals, and I get negative 1.064. No fancy emoji need to be on your calculator. Done. Next up, we're graphing, and so this graph is a logarithm, is again the inverse of, per se, 2 to the x equals y. So what does that mean for inverses, right? The y and the x would switch spots. And if you solve for y, you would get log base 2 of x equals y. Right? So these are very backwards thinking logs. Graphs also realize, right, this time we have a VA of x equals h. Right? So we got hk involved. So, little notes, when you're graphing these, I almost always tell people, switch into this form parent function, meaning before the minus 2's, the negative signs and whatnot, and then you're picking your y's, right? So 0, 1, 2, 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, right? And then you're plugging them in, right? So that's why I generally write it this way, and then deal with, the x is multiplied by negative 1. We're going 4 right, 3 up, right? And again, recognize that your vertical asymptote is x equals h. In this picture, it's 0, but that's because the graph is literally y equals log base 2 of x. And again, common log, reminder that log base 10 would just be written as log, so if you don't see a base, it is base 10. And also, this one would be log base e is ln. Right? We have to deal with e, plug it in our calculators for the power portion. So you wouldn't have something like that on a test or quiz. Moving on, we've got find the domain and vertical asymptote. The logarithmic function, stretch the graph by hand. So again, I'm more focused on the vertical asymptote. Generally, that comes from what's the opposite of what's next to x, right? So this would be x is minus 2. So because, right, think about it, why can't we? Is 3 to what power equals x? Can we ever get x equals 0? And that's why that doesn't work. So in this case, opposite of what's next to x gives us x is minus 2. So I know my graph's going to be something like that for the asymptote. But with this information, right, I've got negative log base 3 of x plus 2 equals y. I right away just look at 3 to the y equals x for my key points. Now I'm picking the y's this time because it's an inverse. 3 to the 0 is 1, 3 to the 1 is 3, and generally that's about all that will fit, right? So focus on those 2 points, and then it's going to look logarithmic. Next, now I'm dealing with multiplying first. What is that negative in front doing, right? Is it affecting the x or the y? It is in front of the whole function, so that's like negative f of x. So it's negative 1 times my y value. So instead of 0, 1, and now 0, negative 1, the x's stayed the same. And then next up, I haven't dealt with the plus 2. Opposite of plus 2 next to the x is minus 2. So I'm subtracting 2 from my y values, getting my final points of negative 1, 0, and 1, negative 1. And remember, because of the negative, it flipped us vertically, so instead of opening up, we were opening down, because we multiplied our y value by negative 1, and that's kind of the look of my graph. It's going to go pretty much straight to the right after that. Next one, we got log base 3 of x plus 5. Okay. Same idea, 3 to the y equals x. This time, notice plus 5 is outside the x, right? They didn't put it in parentheses. So right? Picking 3 to the 0 is 1, 3 to the 1 is 3, kind of similar to the last one. And then the plus 5 only affects the y value. So adding 5 to that, we've got 1, 5, and 3, 6 are my 2 points. There's my point. And then without any movement, my asymptote is x equals 0. And there's my graph. So again, this is the key point to graphing. Give you a couple points and then understand how the transformation is going to move those points. Next one, we got ln, right? So this is e to the y equals x. Again, I only need 2 points, so e to the 0 is 1, e to the 1 is 2.7. Yep, I know it's 2.71 and keeps going, but I don't really need more than that. And how is the minus 3 plus 4 affected? I'm going to add 3 to my x's, subtract 4 to my y's, and this is where my asymptote is. X equals 3 is my vertical asymptote. So similar to that, not quite as straight. And now adding 3 to those points, right? So again, normally I would draw it like this. 1, 0, 2.71. And then you're shifting those points 3 to the right, 4 up. So 3 to the right, 2, 4 up. To give me the point 4 negative, or 4 down, right direction. So 3 to the right, 4 down, 2, 4. And 3 to the right, give me like a 5.7, 1, 2, 3, 4 down. And there's my graph. Not quite the most accurate because I wasn't quite on the right spot, but 5.7, negative 3. And again, my graph's probably not accurate to the nearest tenth, but you just do your best. Last one, I believe. Log base 10 of x minus 2 minus 3, right? So this is 10 to the y equals x. You're only going to be able to fit 2 points on this one. 0 is 1, 1 is 10, if that, right? That's already almost off my graph. Opposite of minus 2 is plus 2, so again, there's my asymptote. And then down 3. So plus 2, minus 3 for these points. 3, 12, 0 minus 3. 1 minus 3 gives me 3, negative 3, and 12, negative 2. So way at the end there. Again, the next point is going to be at, what, 102. So quite a ways away. The last question is, students were taught content from a science class for several weeks. At the end of the last day, and every month after for the next year, the students were tested to see how much material they remembered or retained. The average scores for the group can be modeled by 75, f of t equals 75, minus 6 ln of t plus 1, where t is the time and month after the material score. So what was the average score on the original exam? Right, you're just plugging in 0. And again, you can do this on a calculator. So 75 minus 6 ln of 0 plus 1. 6 ln of 0 plus 1, or just 1. Add an extra bracket, you need it, you get 75%. So 75 was the average score for the first year. What about after 2 months? Same idea, 75 minus 6 ln of 2 plus 1. So now you're plugging in 3 into that. You'll probably do that much math. So again, second enter, but now it's 2 plus 1. We get 68.408%. So over 2 months, they lost about 6.5% on average. What was the average score at the end of 8 months? One last try. And we get 61.817, rounding up. And that wraps up this lesson. As always, let me know if you have any questions.